So for this one, again, this is a tree, right? So draw out your tree for this, and then find these probabilities. Your tree should look something like, you've got different options here, right? Red or blue or green. Find the probability that goes on each of those, and then if you draw red, then what can you draw next? If you draw red or green, or sorry, blue or green, find the probabilities on there. But bear in mind, if I draw a red marble, now I have, I'm not replacing it, so now I have one less marble and one less red marble. So, we'll call that out. All right. So, what's probably I draw a red marble? Yep, there's 2 red marbles out of 11 total. Blue marble? Yep, there's 4 blue out of 11, and the green one there are 5 out of 11. Great. Now, if I draw a red one, now again, like I said, we have 1 less red marble and 1 less marble altogether. So I have 1 out of 10 of them being red. So the probability of drawing a second red marble is 1 out of 10. Blue, I still have all 4 blue marbles left. So probably drawing a blue one is 4 out of 10. And green, if I drew a red one first, I still have all 5 green ones left, so that becomes 5 out of 10. Okay, now what if I didn't draw a red one first? Instead I drew a blue one first. So again, I could draw a red, a blue, or a green second. But now if I drew a blue one first, I still have I have both my red marbles. So I have 2 out of 10 chance of red. Now I have 1 less blue one though. So 3 out of 10 blue and 5 out of 10 green. If instead I had drawn a green one first, I could draw a red, a blue, or a green. But now I have 2 out of 10 red. I have all 4 out of my 10 blue, but now I have 1 less green one. So 4 out of 10 green. Okay, so now we gotta look at the probabilities here. So the probability I draw, the first one is green or red. And remember we talked about this a second earlier, right, with the dice? Didn't we?
Yeah.
Okay. Or means what?
And, or add.
Add. Or means add. So green or red. We're going to add those 2. Green is 5 out of 11. Red is 2 out of 11. So altogether we're going to have 7 out of 11. Good. And for anybody at home, if you're uncomfortable adding fractions, you can just write down this part here and then do it in your calculator to give me a decimal. That's fine. I'm not worried about that. I want to focus on you understanding the concepts here. Blue, then red. That means I draw a blue marble first, then a red marble. So I want to know the probability of getting right there. How do I find that?
411 times 1.
Yep, we multiply along the branch. 4 11s times 2 over 10. You end up with 8 out of 110. Or again, you can just, if you're not trying to multiply them, you can just give me the decimals. Right? Give me this first part, give me that times that, and do it in your calculator and give me the decimal answer. That's fine. The next one is given. So green on second, given blue on first. Has anyone done this one? Do it. Take 15 seconds to do it. So given blue on first means, what's the probability I drew a blue one first?
4 out of 11.
Nope. 100%. If it's given, that means it has absolutely 100% happened. So given blue on first means that I am standing, whoops, wrong way. I am standing right here. Blue first. If I'm standing there, what's probably I draw a green?
5 out of 10.
5 out of 10. That's it. It's as simple as that. Everybody good? Okay. Now, number 14. Survey of 210 students showed that 34 of them like 8 a.m. classes. I claim that 12% of students like 8 a.m. classes is a significance level of 0.05 to test my claim. What kind of problem is this? It's a proportion. Okay, so that's a proportion. How do you do a proportion?
The percent.
Oops. Let me do that. Yep, there's a percent. So this is a proportion. Everyone see that? And is it, what kind of proportion is it? Hypothesis test. How do you do a hypothesis test?
Because there's no confidence in what we're given.
Yep, and it says claim. Everybody all good with those parts? So, I want to take 15 seconds and figure out what computer function am I going to use to describe this. Give me that. What computer function will you use to do this one? Calculator function. Okay, so what calculator function will we be using for this one? Yeah, but if it's a test, it should end in test. If it's a proportion, it should start with proportion or a prop. And there's only one sample, so one prop. So it's going to be one prop z-test. Okay, so go ahead and do your 5 steps, and I'll give you folks a few minutes for this one. Okay, so what is my step? What's my claim, first of all? What am I claiming?
Well, 12% of students like 8 a.m. classes.
Right, so then my claim is going to be, is it going to be a P or a mu?
P.
P. P is what?
Proportion.
Yeah, P is less than, greater than, equal to, not equal to? Equal to what? I claim that 12%, right? That my proportion is 12%.
Yes.
Good? So step 1, H naught is,
P equals 2.12.
yep, and that's my claim. P equals 0.12,
You also get reject.
and you use the word reject later on. Yep, exactly. So then and so then H1 will be,
And not equal to.
yep, P is not equal to 0.12. Step 2, alpha is 0.05. Step 3, one prop Z test, good. And then what are you putting in there?
0.12.
0.12, that's from my claim. So whatever's in my claim, I pop in right there, comma.
34.
So remember, in the proportion, I'm always giving you n and either x or p hat. So what's my n? 210, great. And then 34, it can't be my p hat because the p hat will always have a percent sign on the end of it. So at 34, it's a whole number. That's my x. Good. So it's going to one prop z test of 0.12, comma 34, comma 210, comma not equal to. Is that it?
Yeah.
Okay. And you got a z score of
1.87.
1.86 or 87? 87, and a p-value of
0.0617.
0.617.
Yeah.
Great. So then, in step 4, my p-value, 0.0617, and compare that to alpha, 0.05, and if you don't like decimals, then make them have the same number of decimal places. So it has 4, and it's going to add zeros on the end of that, so they're the same, and then we can see, oh yeah, 517 is larger than 500, which means that I'm going to what?
Fail to reject.
Yep, fail to reject or not reject H naught, same thing. Remember, it's H naught is always what's on trial. We're either going to reject or fail to reject H naught. So here we're not going to reject H naught, which means we do not have enough evidence.
Not evidence to reject the.
Perfect. To reject.
That 12% to like
claim that 12% of students are crazy. Who the heck likes 8 a.m.? All right, so again, this not goes with that not there. Yeah, if you do not reject H naught, you do not have enough evidence, and then the reject drops straight down from step 1. Okay, good. I think your 15 is actually this 15. There.
Yeah.
So for this one, so take. So first off, tell me figure out. Take 15 seconds to figure out what kind of problem this is. What kind of problem is this?
It's ANOVA,
ANOVA. How do you know?
because there's like 3 sections. I don't know what they're called.
Right. Yep, there's labels across the top, not along the side, so it cannot be matrix. A matrix has to have labels across the top and the side. So we only have labels across the top. We have 3 lists. Cannot be linear regression because it only has 2 lists. So 3 or more lists, ANOVA. So this is an ANOVA problem. All right, so everybody do step 1 and step 3 only. We're just going to stick with those 2 because for interest of time. So go ahead and do those 2 steps. Okay, just about everybody's done. It seems like. So step 1 is what? H naught is,
Equals to mu1 equals to mu2 equals to mu3.
yep, there's 3 means and they're all equal. H1 is,
Our plane. No, H naught is our plane.
is it, H1 is at least 1 differs.
This one differs, yeah.
Wait, so that's what we write?
What was that?
That's what we write. We don't write.
Yep. At least 1 differs. Here, I'll write that down. You can't say they're all not equal because you don't know which one's not equal. Does that make sense?
Fair enough.
You don't know whether it's mu2 or mu3 or all of them or what. Step 3, you're going to do ANOVA of L1, comma L2, comma L3.
Yes.
This is your L1, that's your L2, that's your L3. And you're going to get an F statistic of
4.834.
and a p-value of
0.0375.
Yeah, perfect.
good. All right. Now you have number 16 on your sheet. Looks like this. So what kind of problem is this one? Yep, it's a confidence interval,
It has a mean, so it's going to be t and
and it's a mean. Someone see that?
yes. Standard deviation is 1.
So it is, yep, and standard deviation. So, so I would say what you want to do first is figure out what kind, anytime you're talking about chapters 7, 8, 9, 10, 11, think about what computer function you're going to use and kind of start with that. So here, figure out what computer function you're going to use and that you can use that to find your confidence interval and you can kind of backtrack to find the other pieces. So if it is a mean and a confidence interval should end in interval, and mean should start with t. Good. So you can use t interval to do this one. All right, so take a minute. Oh, the other thing I like to do is I like to draw a picture. So I highly recommend drawing a picture. So you have kind of your, you have stuff, you gotta figure out what goes here and here and here and there kind of, if you kind of, that will kind of help you sort of, you kind of think about that. Okay, so you all did T interval of your mean 33.6, comma your standard deviation 7.69, comma 0.9 or 0.90, and you got the interval of what to what?
30.11.
30.1?
30.11.
Okay. I'm gonna write a 3 sig figs, comma,
37.1.
37.1. Okay, so those are the upper and lower limits. Those go here and here. Right? My best point estimate is what? That's my mean. Your best point estimate is your x bar or your p hat. In this case, since it's a mean, it'll be x bar. If it was a proportion, it'd be p hat. Please note, for that, you can't just give me everything. If you write down x bar and s and all sorts of other stuff, you're going to get no credit. You have to either write down x bar only, or label it as the best point estimate. One or the other.
What do you mean?
Like write down BPE, what best point estimate, something like that. So
We can just write it next to this one.
just write down like that, you're fine. As long as you write other stuff too, right? So that goes here. And then remember, I start off with my best point estimate and I subtract my error to get my lower limit, and I add my error to get to my upper limit. So if I want to figure out what my E is, I should probably label these my lower limit and my lower limit, upper limit, and my x bar. If I want to figure out what my error is, I just have to take my lower limit, subtract it from my x bar, or take my upper limit, subtract my x bar, either one. So I'm going to take my x bar minus my lower limit. In other words, 33.6 minus 30.1, and get 3.5. All right. So I think we're on to 17, which looks like this. So let's take a look at this one and think about what kind of problem this is. Just take 15 seconds. Sort out what kind of problem this is. What did you folks come up with? Goodness of it, right? Because there are labels here, but not here, and it's not three or more lists because these are not lists, these are just single numbers. So they're not listed at all. They're just single numbers that go with each category. So this is a goodness of fit test. So for this one, what I'd like you folks to do is again, write down what the H naught is, and then tell me what you do for step 3. Give me your stuff for step 3. Oh, actually, in order to do that, remember whenever we have these, we need to calculate our expected values. So find your expected values, and then give me your H naught, and do step 3. And let me know when you're done.
So don't have the H1 here.
Just clarify. On the exam, you need to show all 5 steps.
Yeah, I got it.
Right, I need all 5 steps for the exam. But for today, since we're a little short on time and want to make sure we get to everything, we're just going to hit the stuff that's different in each one. So we're just going to find the expected values to what H naught is, because H1 you can get easily from H naught, and then do step 3. We're just going to shorten it just for today, not for the exam. Again, show all 5 steps for the exam. Okay, so expected values. Normally there'd be a percentage, like a percentage in each category, but this one isn't like this. This one says that there is no preference. They're all equally preferred. So there's no preference. First you find your n, sample of 100, that's my n. And if they're equally preferred, you split that, divide that equally amongst all the categories. So that means my expected value is going to be 100 divided by 5 categories. And there's no preference. So that's going to be 20. So my expected values for each of these are 20. And then you're going to put this into list 1, this into list 2. Your H naught was O sub I equals E sub I. And then for step 3, you all did the GOF test. I think you did, it's L1, L2, I think it's like 1 and not equal to, is that right?
And the
Oh, degrees of freedom, I'm so sorry. Degrees of freedom. And my degrees of freedom
4.
is equal to number of categories minus 1. So that's 4. Great, thank you. Orion, what did you get for your chi-squared?
18.
18, and your PD?
0.0012.
Good. All right, perfect. Next, we're going to take a look at problem number 18. It's a little bit tricky. I haven't been able to find it. Let me see if I can find it on here. Gosh, I don't have it on there either. So, number 18, we're going to take a look at that one next. But it says, but it's, so, let me see. All right, so I will let you folks work on it, and then we'll talk about it in a minute while I pull it up for the people at home. Here's the problem. What kind of problem is this one? What kind of problem is it? It's a it's a hypothesis test because they talk about testing NBC's claim. And there's a whole bunch of numbers. So this is a mean and a claim. So it's a hypothesis test. All right, so what I want you folks to do is just do for me, find the claim. Step 1, and then step 3. That's it. Okay, so what's my claim? Claim is that, okay, so should it be a mean or a proportion? M or P? Mu or P? P.
Mu.
Mu. Mean should be mu. There should be no P's anywhere. No P's, no P hats. Mu. Mu is what? What about 8.2? So this is what they're comparing it to. It should be what? More than, less than, equal to?
Less than.
You have fewer. So we're saying that the mean should be less than 8.2, which means that my step 1 H naught is that mu is equal to 8.2, and H1 would be, yep, mu is less than 8.2. That is my claim. We're going to use the word support later on. Good. All right, so then step 3, we're going to use, it's a mean, so it should start with T. It's a test. It should end with test. T-test of my H naught should come straight from there, from my claim. 8.2, comma my, comma list 1, right? Because you put this into a list, comma, is it 1?
Then less than.
Less than? Great, and you got a t-value of 2.12, and a p-value of
0.0717.
0.717?
Yeah.
Okay. Is that what else got? No?
0.0358.
Yeah.
Oh, that sounds right.
Okay.
About that, yeah.
358. Is that what everyone's got?
Yeah.
Okay. All right, good. All right, so next we're going to take a look at number 19. So that's this one here. So take a look and decide what kind of problem is this one.